The lesson that we're going to talk about today is how to identify and find the y-intercept of a function. For our current unit, this will be Learning Target 3. Now, we have already talked about finding y-intercepts of functions this year. All right, so this part right here will be a little bit of a review. All right, so when we talk about y-intercepts, okay, it's very important to know what all y-intercepts have in common. All right, so when we talk about y-intercepts, all right, that means where does our function cross, all right, the y-axis. All right, so somewhere along the y-axis, all right, our function will cross. Now, so what do all of these points have in common? Well, they all have in common an x-coordinate of 0. And so then, all right, we have a varied y value for that. So every time we look for a y-intercept, what we are always going to do, all right, is plug in and substitute 0 for x. Now, something that we also need to know is how many y-intercepts can a function have? And I put multiple dots here to kind of help us visualize this. But what we know for something to be a function is that for any input, you can only have one output. So notice, all right, I'm just going to erase a couple of extra points here. I'm going to erase this point and this point here. All right, so if we look, we have a y-intercept here and a y-intercept here. Now, if you think about our conversations from first semester, what we know is this would be two outputs for the same inputs, which means we would not have a function. So what we know then is that all y-intercepts have x equal to 0, and because of this, we can only have one y-intercept per function. All right, so every function will have, okay, that we are going to discuss will have one function. Now, when you get in Algebra 2, right, you'll start talking about some other types of functions like a square root function that might look like this, where you may not have a y-intercept. But for our linear functions, our quadratic functions, and our absolute value functions that we are going to discuss, you will always have one particular y-intercept. All right, so just to summarize, all right, we know that each function will have one and only one y-intercept that we're going to be working with, and it will always be of the form 0y. All right, so how do we use this information to solve for a y-intercept? Well, we simply just plug in for x. All right, so let's look at a few examples here, and we're going to start with our linear functions here. All right, so we know that all functions, all right, are of the form 0 something for our y-intercepts. So all we have to do is substitute 0 into our function, all right, for x. So 4 times 0 minus 3, and follow order of operations. So this would be 0 minus 3. All right, so that would be y equals -3. So our y-intercept would be 0, -3. It's just that simple. So something like this, even though this looks more complicated, it's still the same idea. If we're looking for a y-intercept, we are going to plug 0 in for x wherever that x is. And then we're going to follow our order of operations, all right, to simplify. Okay, so now I have to take care of my parentheses first. So that would be 2/3. 0 minus 3 is -3, and then plus 5. And then 2/3 times -3 would be -2, and then we have our plus 5. So y would equal to 3. So our y-intercept for this guy, all right, would be 0, 3. And we had 0, -3 right here. All right, now the last example for our linear function here is a special case of a linear function. That's when our slope is 0. All right, so we have just y equals 5. And if you recognize this, then what you know is that every y-coordinate ends with 5, all right, which would also include a y-intercept where an x is 0. So this one, you should be able to jump hopefully right to that, all right, answer. Okay, let's look at, all right, some quadratic functions here. All right, so what I'm going to do here is look at, and I'll work one of these, all right, as an example, and then I'll have you pause the video and complete examples 5 and 6. And we're going to look at quadratics in two different forms today. We're going to look at it in vertex form, which is what we have now, and then I'll look at an example in standard form for you. All right, so once again, if we look at number 4 here, all right, we're going to plug 0 in. All right, so I'm going to have, and I'm just going to go just move this up a little bit here. So y equals 3 times 0 minus 2 squared minus 3. Once again, we're going to follow order of operations. So I'm going to simplify inside my parenthesis here. So I'm going to have -2 squared. Then I have to complete my exponent, 3. And the -2 squared, remember, is -2 times -2, which is going to have a positive result. Then I do my multiplication. and we can see that that equals to 9. So my y-intercept here would be 0, 9. All right, and like I said, we've done these problems several times this year. All right, so hopefully this won't be too challenging for you. So what I'd like you to do right now is just go ahead and pause the video and attempt to find the y-intercept for examples 5 and 6, and then turn the video back on to see how you did. Okay, so hopefully you have those two y-intercepts, so I'm just going to quickly work through the problems here. All right, so for this, once again, we're going to plug 0 in for x. All right, and I'm just going to go through the order of operations here so you can see what you should have. All right, so I end up with -2 minus 3, which is -5. So my y-intercept is the point 0, -5. Now notice, I am going back every time and writing it as a point because the y-intercept is a point. All right, and when we start talking about application problems, we're going to want to write it as a point, all right, to help us draw some conclusions about the values and what that might imply. All right, and if I look at the final example here, all right, once again, I'm going to plug 0 in. So 0 minus 2 squared. All right, take care of those parentheses. All right, now once again, that's going to be a +4, and then that's going to lead to -4 there. So the y-intercept here would be 0, 4. Or excuse me, 0, -4. Almost left that negative off there. All right, so that's how we deal with quadratics in vertex form. So let's take a look at a second form here, which is standard form, which we've been discussing the last few days in class. Now, once again, these are even easier, and you'll see that, all right, as we go through an example here. All right, and hopefully you'll do some pattern finding, all right, as we go through these 3 examples, and you might be able to save yourself a little bit of time. All right, so once again, if we're looking for a y-intercept, we're always going to plug 0 in, all right, for x. Now notice we have 2 different x's here, but that's okay. We just plug in, all right, wherever there's an x. All right, and then once again, we do some order of operations here. And so what I end up with is -2 times 0, so that's 0 minus 0, and then plus 6, which is equal to 6. So our y-intercept here is just 0, 6. All right, so once again, just go ahead and pause the video, attempt problems 8 and 9 here, turn it back on, and we'll see how you did. Okay, so hopefully you've managed to get through these problems. So I'm going to do number 8 right here. So once again, all right, 9 times 0 squared minus 12 times 0 plus 9. And then once again, all of this is 0, all of this is 0, which leaves us with 0, 9. All right, if we look at example 9 here, y equals 3 times 0 squared minus 6 times 0 plus 3. Once again, this is all 0, this is all 0, which leaves us 3. All right, so our y-intercept is 0, 3. And let's see, 0, 6, our c value is 6. 0, 9, our c value is 9. 0, 3, yeah, maybe after the third one we see a pattern here, right? Okay, so what we should recognize, hopefully, all right, that is if, all right, our quadratic is in standard form, the c value is in fact our y-intercept. So if you pick up on that pattern, okay, you can go ahead and jump right to that conclusion. Now, remember, if you don't remember the pattern or it slips your mind, you always know that you can plug in, all right, 0 for x and simplify. All right, and let's look at one more type of function, or absolute value function. Once again, we've done this before, all right, but I'm just going to go ahead and do a couple of these with you. Or actually, I'm going to just do the first one here and then have you do the last 2. But once again, it's the same type of process. All right, if we're looking for a y-intercept, we are going to plug 0 in for x, wherever that x is, whatever power it is, and then we're going to follow order of operations. Now, remember, we treat absolute value bars like parentheses. So I'm going to simplify inside of those first, and then you have to take the absolute value of whatever number you have on the inside. Now remember, that result will always be positive because it's referring to a distance, all right, from 0. So the absolute value of -4 is +4. All right, and then we have 12 plus 2, which is 14. So the y-intercept for this first absolute value function is 0, 14. All right, so once again, go ahead and pause the video. Okay, work problems 11 and 12 on your own. All right, and then turn it back on and we'll see how you did. Okay, so let's take a look at these two. And once again, I'm just going to go very quickly here and so you can check your work. So I'm going to plug 0 in for x. I'm going to simplify inside my absolute value bars. I'm going to take the absolute value of 4, which is 4, and then I get to negative 20 plus 5, which is negative 15. All right, so hopefully you came up with this y-intercept as well. All right, so let me scroll down just a little bit here, give me a little bit more room. All right, so, okay, y equals negative 2 times the absolute value of 0 plus 1. Negative 2 times the absolute value of 1. Negative 2 times 1, which is in fact negative 2. And there is our last y-intercept. All right, so that concludes our lesson on finding y-intercepts of functions. All right, so what you should be prepared to do now, all right, is the homework, worksheet unit 6.4. So please come to class with your notes, any problems you have or questions you may have, and then we'll jump right into the homework. See you in class.